Seventh one, work done by force of friction can be zero, can be positive, negative, or any of the above. So as we know that friction opposes the motion, but there are conditions where friction also helps in motion. So let us discuss them in detail. Let us suppose that whenever a body is moving along a horizontal direction, whenever a body is moving along the horizontal direction, okay, by application of some force, it causes a displacement of S, then the direction of the frictional force will be in the opposite direction. So the direction of the motion of the body, whereas the frictional force will be in opposite to the same. Hence, in this case, the work done is positive. General cases, work done is positive. But even though there are cases where the body's motion will be zero, or else the motion of the body, okay, and the force acting on the body, frictional force acting on the body, if they both acting perpendicular to each other, if the displacement of the body as well as the direction of the frictional force, if they both are acting perpendicular to each other, in that case, work done due to frictional force is Fs cos 90, and in this case, work done can be 0. So we have considered an example where work done by the frictional force can be positive. Work done by the frictional force can be 0 when frictional force is acting perpendicular to the displacement of the body. And there is a third case where, very rare cases where the work done due to frictional force can be positive. That means how? Means suppose we are walking on the floor. Whenever we are walking on the floor, what happens means we are pushing the floor in the backward direction. We push the floor in the backward direction. As a result, the frictional force between the foot and the floor pushes the body forward direction. So, while walking, frictional force helps us to move forward. Frictional force helps us to move forward. Okay, in this case, the direction of the frictional force as well as the motion of the body both in the same direction. So, in this case, the work done is considered as positive because frictional force as well as the displacement of the body are in the acting on the same direction. So, work done due to friction can be positive, can be 0, or it can be negative while walking. Hence, the correct option is any of the above. So, work done due to frictional force can be positive, negative, or it can be 0. So, all possibilities are there. So, now moving to the next question, children. Eighth one. Two vectors, force vector as well as the displacement vector are given and asked to find out the work done by the force. So, work done by the force is generally indicated as the product of force vector as well as your displacement vector. Work done is equals to the product of force vector and displacement vector, where the force vector is given as 2i cap plus 3j cap plus 4k cap, and the displacement vector is given as 3i cap plus 2j cap plus 5k cap. So, this is the given value, children. But in order to find out the work done, we have to take the product of force vector as well as displacement vector. Writing the force vector initially, how much is that? 2i cap plus 3j cap plus 4k cap multiplied by the next vector, that is 3i cap plus 2j cap plus 5k cap. So, you have to take the product of these two vectors. So, while taking this, you have to multiply. first vector with the second vector. Again, the first vector is multiplied with the second and as well as third. Okay. Generally, if you multiply such things, you have to multiply 2i with the 3i, the 2i with 2j and 2i with 5k. But when I multiplied by I and I, you know that three perpendicular I, J, K are three perpendicular vectors which lie on the x-axis, y-axis and z-axis. So, I indicates the x-axis, J represents your y-axis, whereas K is the unit vector along z-axis. So, if you multiply I with I, both I and I together are lying on the same axis, that is parallel to each other. Whenever two vectors are parallel to each other, angle between them is 0 degrees. When theta equals to 0 degrees, cos 0 is 1. Hence, work done is simply Fs. So, multiplication vectors. So, 2i into 3i, you will get the value as 2 into 3, 6. I dot I is a unit vector whose value is 1. Its main purpose is to represent the direction only. So, the I dot I you are getting 1. 2 into 3 you are getting it as 6. Done. If you multiply 2i with 2j, 2i is along x-axis and 2j is along y-axis. So, how are these vectors? I and j both are perpendicular to each other. When both are perpendicular to each other, angle between them theta equals to 90 degrees. If theta equals to 90 degrees, cos 90 is 0. So, whenever you multiply I with j, you get the result as 0. Similarly, I multiplied with k also you will get 0 because I and k are also perpendicular. Okay. So, after multiplying this with this, you got it 6. For all other values, you are getting it as 0. Similarly, if you multiply 3j with 3i, you will get the result as 0. J and I, 0. But you multiply j with j, you will get the value as 3 to 6 and j dot j is 1. 3 into 5, 15, but jk is 0, so ignore. Similarly, you have to multiply, other values will become perpendicular vectors, multiply product will be 0. So, final answer is 2 into 3, 6, 3 into 2, 6 and 4 into 5, 20. Hence, the total work done is given as 6 plus 6 is 12 and 12 plus 20 is 32 joules. Hence, the correct option is option 3, that is 32 joules. So, remember children, whenever parallel vectors are there, the product can be taken. Perpendicular vectors, the product is 0. So, I, J, K are called as orthogonal vectors. They only represent the direction on which the vector is being taken. Moving to the next question, 9th one. A force of 1200 Newton, force how much is given? 1200 Newton acting on a stone by means of a rope slides the stone through 10 meters in a direction inclined at 60 degrees. So, let us assume the picture. Here it is 60 degrees. A force acting on a stone is there. Means a rope sliding the stone through a distance of 10 meters. So, how far it is been taken? 10 meters distance it is been considered. The work done by the force is. So, formula for work done is equals to F S cos theta, where the value of force is given as 1200 Newton and the value of displacement caused is 10 meters and theta angle is given as 60 degrees. Substituting in the above value, we have work done is equals to F 1200 S 10 and cos 60 degrees. So, work done is equals to, here you have 1200 multiplied by 10 and cos 60 is your 1 by 2. So, 2 goes 600 times and hence the correct option must be W equals to 6000 joules. So, the option 2 must be true. So, what is the correct option children? Work done is equals to 6000 joules. So, moving to the next one, that is 10th question. A man weighing 80 kgs. What is the weight of the man? 80 kgs man climbs a staircase carrying a 20 kg load. So what is the weight attached to him? 20 kg. What is the weight of the man? 80 kgs. Together they are climbing the staircase. The staircase has 40 steps, each 25 centimeters. Let us visualize this, children. So there is a staircase, something like this, and the person is moving on this staircase, where given the weight of the person as 80 kgs and the load he was carrying along with him, it's something like 20 kg. So 80 kg and 20 kg together climbing the steps. The height, the staircase has how many steps, children? Total 40 steps are there, and the height of each step is given as 25 centimeters. So 25 centimeters into 40, totally you have 25 times of 40 is the distance. 25, 25, 25, 25, 40 times 25. So you will be having something like 1000 centimeters. Well, if it takes 20 seconds to climb, time given is 20 seconds. We are not bothered about time. The work done is, so what is the formula for work done, children? Work done is equals to force multiplied by displacement. Yes, where the force is nothing but the weight himself, the weight that is carried on those steps. What is the weight? One weight is the mass of the man, whereas another weight is the load it is attached. So M1 plus M2 into F equals to MA. Here weight means F is due to acceleration due to gravity, that is M1 plus M2 into G, where M1 is 80, M2 is 20, and the value of acceleration due to gravity is 9.8. So this you will be getting it as 100 times of 9.8 is nothing but 980 Newton. So how much force is acting altogether? 980 Newton. And how much is the displacement, children? The value of the displacement is equals to, each step has a height of 25 centimeters and altogether there are such 40 steps. So the total height will be 25 times of 40 and this is equals to 1000 centimeters. But here 980 is in Newton and this is in centimeters, whereas the options are in SI system. So you have to convert this in SI system. As we know that 1 centimeter equals to 1 by 100 meters, 1000 centimeter must be equals to 1000 by 100 meters. 1000 centimeters is equals to 1000 by 100 meters. Therefore, after further simplification, the value of distance covered by the body is taken as 10 meters. Hence, value of work done W equals to F dot S, which is equals to 980 times of 10. This is equals to 9800 joules. Therefore, the correct option is option 1, 9800 joules. So, total mass into gravity, weight of the body, weight here itself is taken as the force acting on the body, that is 80 plus 20 into G value is generalized 9.8 approximately meter per second square. So, multiplication you will be getting 980 newtons, whereas there are 40 steps, each height is 25 centimeters. So, overall height will be 25 times of 40. You are getting it as 1000 centimeters, and in order to convert centimeters to meters, we have to divide with 100. So, finally, you are getting it as 10 meters and hence the work done is 980 into 10, 9800 joules. So 11th question, the work done by a force F is given and displaces the body from a point 346 to a point 725. Here 346 and 725 indicates the X, Y, Z axis respective, three-dimension picture. Okay. So some motion along X axis, some motion along Y axis and some motion along Z axis. So these motion along X, Y, Z can be represented by taking the unit vectors. I, J, K indicates the direction. I indicates X axis, J indicates Y axis and K indicates Z axis. Similarly, this also, if you want to take the directions, you have to represent with I, J and K respectively. So first of all, let us write the given values, children. The value of F is equals to 3I cap minus 4J cap plus 5K cap. And the displacement delta S is equals to final displacement minus initial displacement, final position minus initial position is the displacement vector, where the value of S1 is given as 346. 346 indicates 3I cap plus 4J cap plus 6K cap, and the value of S2 is equals to 7I cap plus 2J cap plus 5K cap. Clear, children? So, I wrote these three numbers in terms of vectors. Therefore, the value of the displacement vector is equals to final position minus initial position, that is 7I cap plus 2J cap plus 5K cap subtracted by 3I cap plus 4J cap plus 6K cap. So, subtracting the values, we get the position vector as 7 minus 3. You can subtract the vectors which are lying along the same line. You can't subtract the I vector with the J or K vector. So, 7 subtracted from 3I minus 7. Subtracted from 7I is 7 minus 3 is 4I cap, 2J minus 4J is minus 2J, 5K minus 6K is minus K. So, the position vector is 4I cap minus 2J cap minus K cap, and force vector is 3I cap minus 4J cap plus 5K cap. Hence, the work done is equals to F bar dot S bar, which is equals to 3I cap minus 4J cap plus 5K cap times of 4I cap minus 2J cap minus K cap. So, multiplying 3I multiplied by 4I, you are getting it as 4 3s 12. Minus 4 multiplied with minus 2, you will be getting plus 8. 5 multiplied by minus 1, you will be getting minus 5. And this is equals 12 plus 8 is 20. 20 minus 5, you will be getting it as 15 units. Hence, the correct option is option 1, that is 15 units.